Hello everyone. So today we're going to solve a LeetCode problem on isomorphic strings. So we have given two strings S and T, and we have to determine if they're isomorphic. So two strings are S and T are isomorphic. The characters S in S string can be replaced to get T string. So all occurrences of a character must be replaced with another character while preserving the order of the characters. So for example, E is being mapped to A. So for example, the next time E comes, it has to be mapped to A. It shouldn't be mapped to any other different character, because E is already been mapped to A. One character can only be mapped to one character. No two characters can map to the same character. So for example, if E is getting mapped to A in this case, so next time E occurs, it has to be mapped to A. Um, how I can No two characters can be mapped to the same characters, but a character may map to itself. So the first letter we have E, and then the T string we have E. So E can be mapped to E. That is fine, but no two characters can map to the same character. So if E is getting mapped to A, then G cannot be mapped to A again. It has to be mapped to a different character. So when going to the whiteboard to explain more clearly, A is getting mapped to A, fine. G is getting mapped to D, okay, and G is again getting mapped to D, it's fine. So this is an isomorphic string. So in the second example, we have V is getting mapped to C, E is getting mapped to A, and E is again getting mapped to T. But we know that E has already been assigned the value of A character, so it cannot be assigned to a different character. So this isn't an isomorphic string. So we have to return false. And over here we see that A is getting mapped to T, M is getting mapped to U, A to R, G to B, and E to O. So everything is unique here, and so this is an isomorphic string. In the last example, we see that A is getting mapped to A, so a character may map to the same character. That's not an issue. And B is getting mapped to B, and that's also fine. And now C is getting mapped to A. Now here we know that A is already been mapped earlier before, so we cannot use the same character that C can be mapped to. So this is where the condition for isomorphic string fails. And again, D is getting mapped to B. D is getting mapped to B. B is already been occurred before over here. So since B and A has already occurred in the S string, we cannot again use it again. We cannot use it to be mapped by some other character. So while coding this, we can see that. Okay, so we have a string S and string T. So now we shall start our coding. We define the size of our string. Then we map characters to characters. So for that we can write a map. We are mapping characters to characters, and we give it a name as NP. Then we write a set that contains characters. It stores characters and we name it as GP. Then we define a for loop here. For we start from the starting of the string, that is index 0, and less than n that we have specified, and we iterate it. Then inside the for loop, we're going to need to get hold of the character in the S string. So how can we get hold of the character in the S string? By giving cat chs. We should define it as chs, and so we got hold of the character from the S string. And now for the T string, we need to get hold of the character in the T string, so we write T of I. Then we are going to define a for loop. We defined a for loop, and we want to see we want to make an if condition. So here cht is nothing but the character in the string t. So inside the if loop, we're going to give, we want to see if the character has already been mapped to something. So we are going to check if it already has any mapping. We have the mapping or not. So for that, we are going to write mp.find of chs, that is in string s, is not equal to mp.end of. It means that it has already been mapped to something. If it has already been mapped to something, and inside this, you want to write if the character in T string is not equal to MP of characters in S string, then we want to return false. That means we see that the character has already been mapped to something, and we can take this example over here. For example, G has already been mapped to D. Okay, so okay, oops, I wrote this over here. Okay, we see that G has already been mapped to D, so that's fine. Then that is what the if condition says, that the character has already been mapped to something. So G has already been mapped to D. Fine. The next if condition states that um, if this character the next time the G occurs, it should be mapped to D. So if this D character is not being mapped by G, then we return false. So we have to check if the mapping of the D to the previous character is actually G. So G mapping to D, and G is again mapping to D. However, if the previous mapping of the D character is not G, then we have to return false. So after this, we are going to see, we are going to create, we are going to write an else condition over here. Else, if gp dot find out. So this time we are creating a character that is being mapped for the first time. So then we need to add it to the map. But before adding it to the map, we have to check that if it is in the set or not, the character has already been mapped. We have to check if in the set the character has already been mapped. So for that, in the set, we are checking whether the character is mapped. So the set is denoted by GP. So we use the term GP dot find of CSV. We check if the character T in the T string is not equal to gp.end of, that means it has already been mapped. So if it has already been mapped, then we have to return false because it has already been mapped. We can't use it the next time. Yeah. And after, okay, so then we can just add it to our map. We can just add it, add the strings present in in add the characters present in S string, in T string. We're going to map both the S and T string, and then we're going to insert into the set. That is a new character, so that we can again keep on checking whether or not it is present or not there in the GP or the set. Finally, we see that we have gotten all the false conditions, and then um, we say return true, because then if it's not isomorphic string. So if these conditions, if loop satisfies or else loop satisfies, then we return false. Otherwise, if none of the conditions are getting satisfied, then we can just say yes, it's an isomorphic string, and we can return true. So we can see, we can run our code. Okay, there's an error here. Okay. So yes, it is true because E is getting mapped to A, E is getting mapped to D, D is getting mapped to D. Yes, it's true. And the rest of the cases are also like that. P is getting mapped to T, A is getting mapped to I, and P is again getting mapped to T. So I'm going to give submit. And so that is how you do it. This is just one of the ways in which you can solve this question. So thank you for watching.